I'm Kylie Log, and I'm in Dr. Booth's Chem 110 Lab, Section 1. And I'm doing a lab report over experiment number 2, which is reactions of copper and percent yield. To start off the experiment, copper was weighed out and then HNO3 was added. As soon as the nitric acid was added to copper, it turned to a red-orange color gas and fizzed. According to table number 2.1 in our lab manual, the description to match this reaction is NO2, or nitrogen dioxide. The solution then settled and turned to a colorless liquid, producing H2O. Later, water was added and made the solution immediately turn clear blue and formed CuNO3-2. Next, NaOH, or sodium hydroxide, was added. The solution went from a clear blue color to a royal blue. In Table 2.1, the only reaction that produced a royal blue color is CuOH2. After letting the solution settle, it began to crystallize and show that the solution was no longer clear. The observation of the solution crystallizing was actually white salt trying to dissolve, making this NaNO3. The solution was then put on a hot plate and heated. During this process, it is very important to keep stirring the solution to avoid air bubbles of heat being produced, which could cause the specimen to explode. As the solution was stirred, it gradually turned black, this producing the chemical reaction of CuO. Due to the solution being heated, it gave off a vapor, which was H2, or hydrogen. After allowing the particles to cool in the solution, H2SO4 was added. The solution turned clear blue and all the black particles rose to the top. This produced CuSO4. And it is known that this is the right chemical reaction to produce a bright blue water-soluble salt, because when the components of each compound are involved, they must match. So in this case, it is known that SO4 has to transfer over, and CuSO4 is the only option that makes sense. Anyways, after the solution was stirred, all particles went away, forming a colorless liquid, which is H2O. The final step of this experiment was to add zinc. Right after the zinc was added, the solution turned to a bright light blue, immediately forming gas and starting to fizz. Chunks of zinc began to clump together and sank to the bottom. This reaction was ZnSO4. After all the particles were done fizzing, the solution was mostly clear with a clump of zinc. Zinc was displayed after the water was decanted and it turned a dark gray powdery color. So this is where zinc is added. However, the experiment started off with copper, so it must end with copper. This was seen as we left the solution to sit out for a few days. So your end product is copper, or Cu. The percent yield of this experiment is measured by the recovered mass of copper over the initial mass of copper times 100. For my experiment, I got the result of 0.511 grams for my recovered mass over my initial mass of copper being 0.508 grams. So I divided that out to get 1.005 grams. I then times it by 100 to get my percent yield of 100.5%. An example of an experimental error that could have resulted in a percent yield greater than 100% would be the substance being stuck to the beaker or the evaporating dish. This can happen due to chemical reactions not fully finishing. An example of an experimental error that could have resulted in a percent yield of less than 100% would be the decanting process in this particular experiment. When the solution was transferred from the beaker to the evaporating dish, it allowed for multiple particles to be left loose, causing the percent yield to go down. My references for this experiment was Table 2.1, Compounds Encountered in Reactions of Copper, along with pages 7 through 12 in the Chemistry 110 Foundations of Chemistry Laboratory Manual.